Hello friends, welcome to eAdyan. Today in this video we will discuss about optimal busbar joint overlap. Friends, what is the optimal busbar joint overlap? When we design a busbar joint, then the area of overlap on each of the busbar is the question mark. So it should be noted that optimum is for plain bus bar does not include a hole for fixture. So there is a one test conducted with the two bus bars fixed at the center with the bolt, and we have this graph. So here we have resistance ratio on the vertical axis, and horizontally we have overlap or thickness, that is the length of the overlap divided by thickness. So here we can see that the impact on resistance of the joint overlap. The resistance ratio is the ratio of the resistance measured across the joint divided by the resistance of equivalent length of the plain bus bar. From this figure you can see that the streamline effect rapidly decreases until the overlap thickness ratio reaches a value of 2, and when it decreases is slow down and practically stabilizes upon the value of 6 to 7. Here you can see. So upon reaching this value, the current distortion is minimized and the current line becomes parallel. So consequently the optimal overlap length in bolted joint should be 5 to 7 times the bus bar thickness. However, to meet all requirements for the sake of convenience, it's a common practice to make overlap equal to width of the bus bar. Although this procedure is usually satisfactory for bus bars of ordinary dimension, it may not provide sufficient joint contact area on bus bars that have a high thickness to width ratio. Hence, as a thumb rule, the minimum overlap should be from 8 to 10 times the bar thickness. Furthermore, since the actual area of contact is much less than the total area of overlap, the determination of overlap on the basis of width alone is reasonably safe practice only if current density in the contact area does not exceed 1/3 to 1/4 of the current density in the bus bar cross section. So this means that if we have a bus bar that has a width of 30 mm and thickness of 3 mm, the overlap with another bus bar should be 24 to 30 mm. And this is before we put the hole in the bus bar bolted joint. So here you can see if we have a width of bus bar 30 mm, then overlap should be at least 24 to 30 mm, and the condition which must satisfied is the current density in the contact surface does not exceed 1/3 or 1/4 of the current density in the bus bar cross section. The electric contact resistance of the two bus bar is really important. This is determined by the bus bar materials and roughness and on the clamping pressure. So here you can see we have two bus bars, and it is this is the contact area or contact surface over which these two bus bar are connected. So here you can see it is also important the surface roughness of this as well as the pressure that we apply from the both sides. So here Schneider Electric suggests overlap of 5x the bus bar thickness in their frequently asked questions. Greenwood writes usually an overlap of 2 to 3 times the thickness is all that required. Any more doesn't significantly improve the joint but does add a cost and weight. So the more area of contact overlap we keep, it will increase the cost because copper is the costly one. So for practical reasons we may specify overlap as a 5 to 10 times the thickness, which also allows for the holes and slots that we make for bolting these bus bars. The width of bus bar is usually not relevant assuming both conductors are identical. So here earlier we haven't considered the area for holes and slots, but if we take 5 to 10 times the thickness, it will also accommodate the holes and slots. Also above 3 times, however, it is not going to improve much, but since we are making holes, 5 times is good enough. So as a thumb rule, for optimum bus bar joint overlap, for bolted joint and overlap of 5 to 10 times the bus bar thickness is good enough. So friends, I hope you will like this video. Thank you very much and happy learning.